Hello everyone, myself Dr. Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's session on Stokes' Theorem, Part 1. Today I am going to introduce one of the vector integral theorems called Stokes' Theorem, the statement, and I solve one problem on Stokes' Theorem. Now coming to the statement of Stokes' Theorem, let S be an open surface bounded by a closed and non-intersecting curve C, and f bar is any differentiable vector point function. Then Stokes' theorem states that the line integral f bar dot dr bar is equal to the surface integral of curl f bar dot n bar ds. So once again I repeat, by Stokes' theorem, the line integral f bar dot dr bar is equal to surface integral curl f bar dot n bar ds. So to apply Stokes' theorem, the line integral must be in the form of f bar dot dr bar. Similarly, the surface integral must be in the form of curl f bar dot n bar ds, where n bar is the outward drawn unit normal vector to the surface. So, to apply Stokes' theorem, first we need to calculate f bar dot dr bar. Similarly, curl f bar dot n bar. There are two types of problems: applications of Stokes' theorem, that means evaluate the line integral using Stokes' theorem. So we transform the line integral into surface integral, or evaluate the surface integral using Stokes' theorem. Then we transform the surface integral into line integral and verify Stokes' theorem. That means we need to find both LHS and then RHS, and finally we prove that LHS is equal to RHS. Now let us solve one problem. Here, verify Stokes' theorem for the function f bar integrated round the square in the plane z equal to 0, whose sides are along the lines. So here x equal to 0, y equal to 0, x equal to a, y equal to a. The lines are given. Now we need to verify Stokes' theorem for the given f bar. So given f bar equal to x square I bar plus xy j bar. Now to verify Stokes' theorem, we have to prove that the line integral f bar dot dr bar is equal to surface integral curl f bar dot n bar ds. So that means we need to evaluate LHS and then RHS. We need to evaluate both LHS and RHS. So to evaluate LHS, we need to calculate f bar dot dr bar, and to evaluate RHS, we need to calculate curl f bar dot n bar ds. So let us consider the LHS. That means let us find f bar dot dr bar. So we have r bar is xi bar plus yj bar, because in the plane z equal to 0. That means xy plane. So dr bar is dx I bar plus dy j bar. That implies f bar dot dr bar, the dot product between two vectors. The result will be a scalar. So here, what is the dot product between these two vectors? Simply sum of the products of corresponding components. So here the first component is x square and here dx. X square dx and plus xy dy. This is f bar dot dr bar. Similarly, we need to find curl f bar also. What is curl f bar? That is del cross f bar. So I bar dou by dou x. So what is del cross f bar? I bar, j bar, k bar. The first component, the components of first vector, dou by dou x, dou by dou y, dou by dou z, and components of second vector, f1, f2, f3. So which is I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. Now x square is the first component, xy is the second component, and 0 the last one. So if we evaluate this determinant I bar into, so dou by dou y of 0 minus dou by dou z of xy minus j bar into dou by dou x of 0 minus dou by dou z of x square plus k bar into the last one dou by dou x of xy minus dou by dou y of x square. Now this is equal to, here dou by dou y of 0, 0, and we are differentiating partially with respect to z, so we will treat x and y as constant, so completely 0 into I bar, and here again 0, 0 plus 0 into j bar, and here dou by dou x of xy, so y is constant and here it is 0, so y k bar. So here we get y, whereas we are differentiating partially with respect to y here and the function is x square, so we get 0. So simply y into k bar, that is curl f bar. Now what is n bar? In the case of in xy plane, the outward drawn unit normal vector n bar is simply k bar. So therefore curl f bar dot n bar is equal to, what is curl f bar? Y k bar dot k bar. The answer is y. So we have evaluated both f bar dot dr bar and curl f bar. Now let us consider the RHS first. What is RHS? Surface integral curl f bar dot n bar ds, which is the double integral curl f bar dot n bar is y dy dx, and we need to find the limits. Here the surface is bounded by the lines x0, y0, xa, ya. So if you draw that x-axis, y-axis, origin, so this is the line y equal to 0 and this is the line x equal to 0 and x equal to a, so here, and y equal to a, so that means it's a square. This is x equal to a and this is y equal to a. Now if you find the points here, this is the origin and this is the point a comma 0, and this is the point b, a comma a, and here c 0 comma a. On y axis the value of x is 0. So here origin is 0 0, a comma 0, b, a comma a, and c is 0 comma a. So here it is very clear that here what is the value of x? 0, and here it is a, and here y equal to 0 and here y equal to a. So y changes from 0 to a and x also changes from 0 to a. So therefore this is equal to x from 0 to a, y from 0 to a, y dy dx. So x from 0 to a, y square by 2, 0 to a. The integral of y is y square by 2, and applying the limits, upper limit is a, so a square by 2 comes out, integral dx from 0 to a. Now again integral dx is x from 0 to a, so upper limit a cube by 2. Upper limit is a, so a square into a is a cube by 2. So this is RHS. Now coming to LHS, what is LHS? The line integral f bar dot dr bar, which is, line integral means we need to evaluate the integral along each line or each curve. So here this is sum of along OA plus line integral along AB plus line integral along BC plus line integral along CO. So this is sum of 4 line integrals. We need to calculate one by one. Now the first one along OA. Now along OA, what we can observe along this line OA, the value of y is 0. If y is 0, then dy is 0 and x changes from 0 to a. So therefore along OA f bar dot dr bar is equal to x from 0 to a. Now what is f bar dot dr bar first? That is calculated already. F bar dot dr bar is x square dx plus xy dy. X square dx plus xy dy. Now from x equal to 0 to a, x square dx, and since y is 0 and dy is 0, this term vanishes. So the answer is x cube by 3 from 0 to a. So a cube by 3. The first one is over. Now we need to calculate the second along AB. Second along AB. So along AB, what we can observe in this square, along AB the value of x is fixed, x equal to a. So along AB x equal to a, if x is a constant, dx will be 0 and y changes from here y equal to 0, whereas here y equal to a. So 0 to a. Therefore along AB f bar dot dr bar is equal to y from 0 to a. Now what is f bar dot dr bar? And here dx is 0, x is a. So x square dx plus xy dy. F bar dot dr bar is x square dx plus xy dy. Now x equal to a. So a square dx is 0 plus a into y dy. So simply a constant, integral y dy from 0 to a, and integral of y is y square by 2, and applying the limits we get again a cube by 2, a square by 2 into a cube by 2. Now coming to the third line along BC. Now along BC, along B to C, the value of y is fixed, y equal to a. So along BC, y equal to a, that implies the derivative is 0 and x changes from here the value of x is a and here the value of x is 0. So x changes from a to 0. So therefore along BC f bar dot dr bar is equal to x from a to 0, dy is 0, so the second term vanishes, and what remains? X square dx. So which is x cube by 3. So here y equal to a and dy is 0. So obviously the second term vanishes. So x cube, and here the integral of x square is x power 3 by 3 from a to 0. Upper limit 0, lower limit minus a cube by 3. So the answer is minus a cube by 3. And now the fourth one along CO. Along CO. So C to O, the line is y-axis, so x equal to 0. Along CO, x is 0. So that implies dx is 0. And y changes from, at C the value of y is a, and at Z origin the value of y is 0. So y changes from a to 0. Therefore, the line integral along CO f bar dot dr bar is equal to y from a to 0. Dx is 0, so the first term vanishes, and then second term xy dy, but x is also 0, so 0 into y dy. So the answer is 0. Hence we have evaluated the line integral along each line of the or each side of the square. Now the line integral f bar dot dr bar along C is along OA plus AB plus BC plus CO. Now along OA, the first value is a cube by 3, and along AB it is a cube by 2, and along BC minus a cube by 3, and the last one is 0. So these two gets cancelled. So a cube by 2. This is LHS. And what we have obtained RHS that we have evaluated in the initial stress. So we got RHS is A cube by 2. RHS is A cube by 2. From these two, LHS is equal to RHS. Hence, the Stokes theorem is verified. So like this, we verify whether the theorem can be satisfied for the given F bar or not. Obviously, LHS and RHS will be the same. Obviously, we will get the same answer for both LHS and RHS. So this is for today's session, and in the next session, I will continue the same topic, and we solve some problems on Stokes theorem, the applications of Stokes theorem. Thank you.